Article 312.8c4 of the National Electrical Code specifically addresses the use of wire nuts in panel boards within nursing homes. The code explicitly states that in nursing homes, wire nuts or other non-insulated terminals shall not be used within a panel board. This regulation stems from the heightened safety and reliability standards mandated for electrical systems in healthcare facilities. Several factors contribute to this prohibition. Firstly, insulation damage. Wire nuts rely on twisting and crimping to establish a secure connection. Over time, vibrations, movement, or improper installation can compromise the insulation of the wires, increasing the risk of electrical hazards. Secondly, loose connections. Wire nuts are susceptible to loosening over time, which can lead to arcing, overheating, and potentially fires. The integrity of the connection is crucial in a healthcare setting where electrical failures can have severe consequences. Thirdly, moisture penetration. Wire nuts are not inherently moisture-proof. In humid environments, this can lead to corrosion and electrical faults, further compromising the reliability of the electrical system. Given these concerns, the NEC mandates alternative methods for making electrical connections within panel boards in nursing homes. One acceptable practice is the extension of existing wires. It is permissible to extend existing wires to reach the breakers in a panel board, provided certain conditions are met. The wire must be properly sized and rated for the circuit to ensure it can handle the intended current load without overheating or causing a voltage drop. The extension must be made using approved methods, such as solderless connectors or stranded wire with crimped terminals. These methods provide a more secure and reliable connection compared to wire nuts. The extended wire must be securely supported and protected from damage to prevent strain on the connection and potential insulation issues. Terminal blocks are another commonly used alternative in panel boards. Terminal blocks provide multiple connection points for wires, offering a more organized and secure method of terminating conductors. They are typically rated for high current and voltage, making them suitable for various electrical applications. Their design ensures a reliable and stable connection, minimizing the risk of loose connections and electrical faults. Insulated wire connectors are also acceptable for connecting wires in panel boards. These connectors are similar to wire nuts but feature a protective insulation cover. This cover provides an additional layer of safety by preventing accidental contact with live conductors and reducing the risk of electrical shock. When extending wires, several factors must be considered to ensure a safe and code-compliant installation. Firstly, conductor sizing. The conductor used for the extension must be of the correct size to handle the ampacity required by the circuit. This is determined by the overcurrent protection device, such as the circuit breaker, and the type of load connected to the circuit. Using a conductor that is too small can result in overheating and potentially cause a fire. Secondly, insulation type. The insulation type of the conductor must be appropriate for the application and the environment in which it is installed. Factors to consider include temperature rating, moisture resistance, and resistance to chemicals or other environmental factors. Using the wrong type of insulation can lead to premature failure and electrical hazards. Thirdly, connection methods. The method used to connect the extension to the existing wire must be approved and reliable. Solderless connectors, such as crimp connectors or set screw connectors, are commonly used for this purpose. These connectors must be properly installed and tightened to ensure a secure and long-lasting connection. Fourthly, support and protection. The extended wire must be properly supported and protected from damage. This can be achieved by using cable ties, clamps, or other means of securing the wire to the panel board or other supporting structures. The wire should also be protected from physical damage, such as abrasion or impact, by routing it in a safe and protected manner. When using terminal blocks, it is important to select terminal blocks that are rated for the voltage and current of the circuit. Terminal blocks are available in a variety of sizes and configurations, so it is important to choose the right ones for the application. Terminal blocks must be properly installed and tightened to ensure a secure connection. Insulated wire connectors offer a convenient and safe way to connect wires in panel boards. These connectors typically consist of a metal crimp connector surrounded by an insulating cover. The cover provides protection against accidental contact with live conductors and helps to prevent short circuits. Insulated wire connectors are available in a variety of sizes and colors to accommodate different wire sizes and applications. When using insulated wire connectors, it is important to choose connectors that are rated for the voltage and current of the circuit. The connectors must be properly crimped using the correct crimping tool to ensure a secure and reliable connection. The installation of electrical systems in healthcare facilities, including nursing homes, is governed by specific requirements outlined in the National Electrical Code and other applicable standards. These requirements are designed to ensure the safety of patients, staff, and visitors. In addition to the prohibition of wire nuts and panel boards, other key considerations include the following. Firstly, grounding. Proper grounding is essential for protecting against electrical shock and preventing equipment damage. All electrical equipment and systems must be properly grounded in accordance with the NEC. This includes grounding the panel board enclosure, the neutral conductor, and any exposed metal parts. Secondly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect circuits from overloads and short circuits. These devices must be properly sized and installed to provide adequate protection. The NEC provides specific requirements for overcurrent protection based on the type of circuit and the load it serves. Thirdly, wiring methods. The wiring methods used in healthcare facilities must be appropriate for the environment and the application. The NEC specifies approved wiring methods for different types of occupancies, including healthcare facilities. These methods include conduit, cable, and other wiring systems that provide adequate protection against physical damage and electrical hazard. Fourthly, emergency power systems. Healthcare facilities are required to have emergency power systems to provide backup power in the event of a power outage. These systems must be designed and installed in accordance with the NEC and other applicable standards. The emergency power system must be capable of providing power to essential loads, such as lighting, life support equipment, and fire alarm systems. Fifthly, isolated power systems. Isolated power systems are used in critical care areas, such as operating rooms and intensive care units, to protect patients from electrical shock. These systems isolate the electrical supply from ground, reducing the risk of leakage current and electrical hazards. The NEC provides specific requirements for the design and installation of isolated power systems. In summary, the prohibition of wire nuts in panel boards in nursing homes is just one aspect of the comprehensive set of safety requirements for electrical systems in healthcare facilities. By adhering to these requirements, electrical professionals can help to ensure the safety and well-being of patients, staff, and visitors. The specific section of the National Electrical Code, NEC, that prohibits the use of wire nuts and panel boards within nursing homes is Article 312.8c4. This section is located within Article 312, which generally covers cabinets, cutout boxes, and meter socket enclosures. The specific subsection C4 addresses the unique requirements for nursing homes. Understanding the precise location of this code reference is crucial for electrical inspectors, contractors, and facility managers to ensure compliance with the NEC. The rationale behind prohibiting wire nuts in nursing home panel boards is multifaceted, primarily focusing on enhancing safety and reliability within these sensitive environments. The prohibition addresses several potential hazards associated with wire nuts, particularly in settings where vulnerable individuals reside. Insulation damage is a significant concern. Wire nuts rely on a twisting and crimping action to establish a secure electrical connection. Over time, factors such as vibrations, physical movement, or improper initial installation can degrade the insulation of the connected wires. This degradation increases the risk of electrical shorts, ground faults, and potential electrical fires. In a nursing home, where residents may have limited mobility and responsiveness, the timely detection and mitigation of such hazards are paramount. Loose connections represent another critical risk. Wire nuts are prone to loosening over time due to thermal cycling, mechanical stress, or improper installation. A loose connection increases the electrical resistance at the joint, leading to localized heating, arcing, and potentially escalating into a fire. Regular maintenance and inspections are necessary to identify and rectify loose wire nut connections. Nursing homes often lack the resources or expertise to conduct such frequent inspections, making the prohibition of wire nuts a proactive safety measure. Moisture penetration poses a further challenge. Wire nuts are not inherently moisture-proof or resistant to humid environments. In areas with high humidity or potential water exposure, moisture can penetrate the wire nut, leading to corrosion and eventual electrical failure. This is particularly concerning in nursing homes where plumbing leaks, cleaning activities, or condensation can introduce moisture into electrical systems. The resulting corrosion can compromise the integrity of the electrical connections, increasing the risk of electrical hazards. Acceptable alternatives to wire nuts in nursing home panel boards include several methods that provide more secure and reliable electrical connections. These alternatives aim to mitigate the risks associated with wire nuts and enhance the overall safety and longevity of the electrical system. Extension of existing wires, with specific precautions, is an acceptable practice. Extending existing wires to reach circuit breakers or other termination points within a panel board is permissible, provided the stringent conditions are met. The wire used for the extension must be properly sized and rated for the circuit's current carrying capacity. The extension should be made using approved connection methods such as solderless connectors or crimped terminals, which provide a more secure and reliable connection compared to wire nuts. The extended wire must be adequately supported and protected from physical damage or strain to prevent loosening or insulation failure. Terminal blocks offer a robust alternative to wire nuts. Terminal blocks provide designated connection points for multiple wires, offering a secure and organized method of terminating conductors within the panel board. Terminal blocks are typically rated for high current and voltage applications and are designed to maintain a stable and reliable connection over extended periods. They also facilitate easier troubleshooting and maintenance, as individual connections can be easily accessed and tested. Insulated wire connectors represent another acceptable option. Insulated wire connectors are similar in function to wire nuts but incorporate an additional layer of insulation to enhance safety. These connectors typically consist of a metal crimp connector enclosed within a protective insulation cover which prevents accidental contact with live conductors and reduces the risk of electrical shock. Insulated wire connectors provide a secure and reliable connection while minimizing the potential for electrical hazards. When extending wires in the panel board, several critical factors must be considered to ensure code compliance and safe operation. Firstly, conductor sizing is paramount. The conductor size must be appropriate for the ampacity of the circuit. Selecting the correct conductor size is crucial to prevent overheating, voltage drop, and potential fire hazards. The conductor size is determined based on the circuit's overcurrent protection and the type of load it serves. Secondly, insulation type is a key consideration. The insulation type must be suitable for the specific application and the environmental conditions within the panel board. Factors such as temperature rating, moisture resistance, and resistance to chemical exposure should be taken into account. Using the wrong insulation type can lead to premature degradation and potential electrical failures. Thirdly, connection methods must be carefully selected. The method used to connect the extension to the existing wire must be reliable and approved for the application. Solderless connectors, such as crimp connectors or set screw connectors, are commonly used and must be properly installed and tightened to ensure a secure and long-lasting connection. Fourthly, support and protection are essential. The extended wire must be adequately supported and protected from physical damage. This can be achieved by using cable ties, clamps, or other means of securing the wire to the panel board or surrounding structures. The wire should also be protected from abrasion, impact, or other potential sources of damage. When utilizing terminal blocks in a panel board, careful selection and installation are critical. Terminal blocks should be chosen based on their voltage and current ratings to ensure they are compatible with the circuit requirements. They are available in various sizes and configurations to accommodate different wire gauges and connection densities. Proper installation involves securely mounting the terminal blocks within the panel board and ensuring that all connections are tightened to the manufacturer's specifications. Insulated wire connectors offer a convenient and safe method for connecting wires in panel boards. These connectors typically consist of metal crimp connectors surrounded by an insulating cover, providing enhanced protection against electrical shock and short circuits. When using insulated wire connectors, it is crucial to select connectors that are rated for the voltage and current of the circuit. The connectors must be properly crimped using the appropriate crimping tool to ensure secure and reliable connection. In healthcare facilities, including nursing homes, electrical systems are subject to stringent regulations and standards aimed at ensuring patient safety and preventing electrical hazards. These regulations are typically enforced through inspections and compliance audits conducted by regulatory agencies and accreditation organizations. Grounding is a fundamental aspect of electrical safety in healthcare facilities. Proper grounding ensures that electrical equipment and systems are connected to a common ground, providing a low impedance path for fault currents to flow back to the source. This helps to minimize the risk of electrical shock and equipment damage. The NEC provides detailed requirements for grounding electrical systems, including the use of grounding electrodes, grounding conductors, and bonding techniques. Overcurrent protection is another critical component of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overloads and short circuits. These devices must be properly sized and installed to provide adequate protection for the circuit and prevent potential fire hazards. The NEC specifies requirements for overcurrent protection based on the type of circuit and the load it serves. Wiring methods in healthcare facilities must be carefully selected to ensure safety and reliability. The NEC provides specific requirements for wiring methods in healthcare occupancies, including the use of conduit, cable, and other wiring systems that provide adequate protection against physical damage and electrical hazards. Wiring methods must also be installed in accordance with the manufacturer's instructions and applicable codes. Emergency power systems are essential for maintaining critical functions during power outages in healthcare facilities. These systems provide backup power to essential loads such as lighting, life support equipment, and fire alarm systems. The NEC and other applicable standards specify requirements for the design, installation, and maintenance of emergency power systems, including regular testing and maintenance to ensure their reliability. Isolated power systems are used in critical care areas, such as operating rooms and intensive care units, to protect patients from electrical shock. These systems isolate the electrical supply from ground, reducing the risk of leakage current and electrical hazard. The NEC provides specific requirements for the design and installation of isolated power systems, including the use of isolation transformers, line isolation monitors, and other specialized equipment. In conclusion, the prohibition of wire nuts in panel boards within nursing homes is a critical safety measure aimed at preventing electrical hazards and ensuring the well-being of residents. Compliance with this requirement, along with adherence to other applicable codes and standards, is essential for maintaining a safe and reliable electrical system in these facilities. By understanding the rationale behind the prohibition and implementing acceptable alternatives, electrical professionals can contribute to creating a safer environment for patients and staff in nursing homes. Article 312.8c4 underscores the importance of proactive safety measures in healthcare settings where vulnerable populations reside.